Hello and welcome to another episode of Invalid Entry. My name is James Taylor and we've got a special day. It's the 256 subscriber special. So thank you very much for everyone who's subscribed. I wanted to do something a little bit different to my normal videos, programming and tech like that. And my friend Webcaller was like, well, you could do one on binary numbers. Binary numbers, absolutely fantastic idea. And then he had a better idea. You could do it on 0000001 and do it on endianness. It's like, yes, I could really rant about endianness or how there's not always 8 bits in the byte. That's another favourite topic to trigger me off. And then he quite genuinely said, what do you mean there's not 8 bits in the byte? So we are now doing it on the 11111111 subscriber special. And some of you out there saying, hold on, that's only 255. So yeah, because one of the subscribers is me. And if you think that's the most egotistical thing I've ever done in my life, you're really not even near that level. So yeah, we are the 255 subscribers plus myself. Video that I'm going to let you guess is big or little endian as you like, really. So the question is, how many bits are in the byte? And everyone's turned off going, well, it's quite obviously 8. Bytes have 8 bits, nibbles have 4 bits. Words are a little bit more complicated, and I won't go into words or multi-byte values. There'll be a bonus video on that. And the answer there is not quite true to any of the first two statements. In fact, the real question is, if we look at the Wikipedia page, it answers it really, really nicely. It says the byte is a unit of digital information that most commonly consists of 8 bits. And when we say most commonly here, when you say, if you say, oh, this animal is a common animal, it means everyone's seen it. The probability is that anyone watching this video has never seen a computer which does not use an 8-bit byte. Or if it uses less than 8 bits in that computer, like some kind of pocket calculator, it isn't really a computer. Like, we don't even think of it as a computer. So even credit cards, which are computers, they're 8-bit computers. They are 8-bit computers, not something else. And I think this is where it comes from, is that it is so common these days. It is prevalent. Oh wow, that's a difficult word. That you would just not find, except for in a museum, a computer which does not use 8 bits. But it doesn't mean to say the answer is 8 bits. In fact, the best programming language to handle this nicely is actually .NET, where you're using the serial adapter. You can actually change the number of bits in your messaging, because you might be interacting with old legacy interfaces which use a different number of bits. 8 is a good answer, and the size generally is hardware dependent, because you're generally talking about the number of wires on your device that goes in and out of memory or in and out of processors. But yes, 6 and 9 bits are common, especially in the 1950s and 1960s. It's so common, in fact, that one of the really important landmark computers used something called BCD. Now, BCD is usually we call binary coded decimal, but it also refers to the equivalent of ASCII. So in the day, they had a thing called ASCII here, which had a table which looks like this. And you might notice the ABC comes lower in the memory, or higher in the memory than the Z. I think that's because the endian was backwards. Now, you said that was actually used on a computer which was the IBM System 360. The IBM System 360 was one of the first mainframes which was like affordable. In my opinion, this is. It was a massive, it was rolled out by IBM on a really massive level. And actually what's really interesting about this is it's really well documented how they sort of built it, not in the technical aspects of it, by the Mythical Mammoth. This was by a guy called Fred Brooks. If you've never heard of the Mythical Mammoth, that's the entire project management for IT based upon adding more developers to a project doesn't always make it better. And actually it's referenced by more modern books like Code Complete, where he said, if you haven't read this, go and read it. It's a very slim book, and it is really worth reading if you're interested in the history of software development. And it also, I think, he goes further than that. He talks about them replacing file-based documents with microfiche, and these days we'd use wikis. So you look about the tooling around developing software. This book talks about around developing software. It's probably the best books about how to build systems, which isn't actually the technical aspects, about the soft decisions. And it was really made about the OS 360 IBM, which of course this computer, which was rolled out massively, which used a 6-bit computer. And what's really interesting is as they rolled that out, the IBM were also, being a big company, left hand and right hand doesn't do, they're also part of the standard to have an 8-bit byte, the ASCII standard, which is now what we use. Usually we're moving to UTF-8, UTF-16 and those things to get more characters, but really the 8-bit byte has become the definition. So, I have seen this question asked genuinely in interviews. I have been in interviews where someone else on the panel has asked this question, and I have gone, well, that's a terrible question, because the answer is whatever number you would like. But if you say 8 bits, that's the safe answer, but the answer is not always 8 bits, especially on legacy computers. So, 8 actually is a fantastic answer, though. And if I was, the next question might go, well, if I was going to build a computer from scratch, how many bits would I put in the byte? And I'd say probably 8. And the reason for that is that, first of all, I want to interface with other computers. I'm going to want to compile my computer down to that computer, and 8 bits is make everything interoperable really helps. When they were trying to make a language called EBIDIC, which was based on the binary code, it's the extended binary code, they moved it from 6 to 8 bytes. But they found that there were lots of problems because the encoding of the letters were different. If you had a program which said start at A and print a character until you end up at Z, on ASCII that prints A to Z, and on EBIDIC that prints 48 characters because there's some extra blank characters in there. Trust me, it's horrendous. So yeah, basically 8's a good answer because it's on the power of 2 set, so you can say it's 2 to the 3. Which means it doubles nicely, which means every time you double it, it's also on the powers of 2 set, which if you're doing binary is very powerful. So it's a very good answer because it's on that set. So 4, 8, 16 bits, they're nice numbers in that respect. 10 would be a good answer as well, but 10 has its own problems because 8 divides and quarters nicely. So you can divide an 8 by half, you get 4 bits. You can divide it by 4 and you can get 2 bits. If you take something like 6, you can divide that in half nicely, so you get 2 halves of 3 bits, but you can't divide that again. And same for 10, you can divide that into 5, but then you can't divide that again. So it's really nice that it both divides into halves. But also I think that if there is a uint 8, which obviously is an 8-bit uint, but if you have a 1-byte integer, which we would call uint 8, but if a 1-byte integer, both an int and a uint, an unsigned int, have nice ranges. So for example, 128 is just over 100. So you can fit 100 things in a signed int, plus or minus 100 things, which I really like that. 256 is a good range as well. You can have 4 of them make 1,000, although if you can use 4 bytes as BCD. So if you're doing BCD stuff, these are and they're also not too big. So if you want to have flags, for example, you can store 8 flags. It's not too big if you only want a couple of flags that are having a whole byte. It doesn't start using up an awful lot of memory in terms of actual transistor bits. So if you start going to 10, I've read some computers have a 42-bit byte, and if you're going to use 1 bit in the byte as a flag and the rest is just rubbish, you're using up a lot of extra transistors, which really matters. It really does matter when you start, scaling, copy and pasting transistor blocks on your design. So yeah, 8 is a good answer for the number of bits in a byte. The other thing is, to clear up this confusion, there became a new standard called an octet. An octet has 8 bits. It's the definition of an octet. There is definitely no other answer for octet. There are no octets with 7 or 6. There's no octets with 10 bits. And the next statement is also good, is bytes are usually octets. 99.99% of the time they're octets, unless you're in a museum. And that's what it comes down to, is that these are good numbers. So that's it. That is the reason, that is the history behind. There are computers out there which have different numbers that you can go to museums, you can look at them. And the thing about museums is, often when people think about museums, especially younger kids think about museums, these computers are almost out of reach. And they're like looking at mummies and sarcophagi and saying these are thousands of years old. These computers are within living memory. My parents, both of them, worked on these type of computers which had different bytes. They lived in that era where you had to swap encoding types of characters, and they're still alive, they're still around. And my dad, we recently went around the Science Museum in London, and my dad was both humorous and offended by some of the things they had on the exhibit, because he's like, no, that's a perfectly viable bit of technology, we can still use that. Which is quite amusing to my daughters, who are like, no, this isn't a computer. But yeah, these things do exist. They are still used. You do sometimes hear I've never seen one of these computers in use in the modern, like, last 5-10 years. I sometimes hear stories of someone has one of these in a in a basement somewhere still churning out things. I think more likely these days they've just been emulated, so they have a program or something that's been running for 30 years. It's been emulated. So yeah, I'd be surprised if anyone's actively running one, what I say, in anger, like outside of a museum or history context or an educational context. But there are sometimes use cases. The other big thing these days are supercomputers generally use commercially, lots and lots of commercially available chips. So they, again, generally fall into that 8-bit situation. There are also some situations, very, very briefly, where you may on a bus have an extra line or two which are not technically part of the data. So you look at some of the things like trust zone technology, where they may have a bus with words going down the bus or with data going down the bus with an extra bit on the bus which tells you whether it's in trusted or not trusted mode. But yeah, that they are special cases, and they're not really that bit is not really part of the actual byte. It's more like metadata around the information going across the bus. So that's it. It is something I can, if I had a pint of beer, continue this discussion about how many bits is a good idea for another 2 or 3 hours, I think. But I'm going to stop there, and thank you very much for everyone who subscribed. And if you enjoyed this, please leave a comment, like and subscribe, because there's going to be more of these. Hopefully when we meet the 512th subscriber, I won't discuss this again. I will try never to bring it up. And I just ask you not to do the same when I'm busy, because it does trigger me, and I do just go, no, there are things there where you don't have 8-bit bytes. So thank you very much, and I will see you all in the next episode.